The converse of Theorem 7 says to us that if the alternate angles between lines intersected by a transversal are equal, then the lines are parallel. And we write this in short to say alternate angles are equal. This is to say that the given information, or what we start knowing in this theorem, is that the alternate angles between lines that are cut or intersected by a transversal are equal. Now, what do we have here, or when you look at it in a diagram, what does it mean? It means that if we have line L1 and line L2 that is cut by a transversal, now when we measure the alternate angles, meaning angle A1 and angle A2, we find that they are the same. We know here that they're the same. The alternate angles are equal. We can then conclude to say these two lines L1 and L2 must be parallel to each other. Remember here, we don't know, we are not told if they are parallel. We just know that there are lines that are cut by transversal and the angles are the same. So the angles will only be the same if these two lines are actually parallel to each other. Now, this is to say that if line L1 was sitting like this, and we have line L2 sitting like that, the transversal will be in such a way that it cuts them like that way. And you can see that the alternate angles here are not the same. And as a result, these two lines will eventually intersect here. That means they will never be parallel to each other. So they get to be parallel to each other only when these angles are the same. So if we have line A, L1 like that, and we shift it so that it comes like that, do you see that we are reducing this angle, we're making it to be smaller, and that would mean that it will not be parallel to this line as a result. So we then conclude that these two lines must be parallel. L1 must be parallel to L2. And it is important to also notice that this is the third converse in which we can use it to prove that lines are parallel. So there's three ways in which we can prove that lines are parallel. One of the first ways is to prove that corresponding angles are equal. The second way is to prove that co-interior angles are supplementary. And the last way is to prove that the alternate angles are equal. Then you'll be able to conclude that the lines involved must be parallel to each other. To conclude theorems that deal with parallel lines, we said that we should look for an F shape, a U shape, and an N shape. Or sometimes we actually look for an F shape, a U shape, and a Z shape. Now, this becomes a real question for you. Do you find Euclidean geometry to be fun or to be a fuss?